Hey everyone, welcome back to the channel. Today we are looking at something absolutely vital for your code, how to handle errors so your Python scripts never crash unexpectedly. If you ever written a program that works great until a user types the wrong input or hit a messy red error trace, you know how frustrating that is. Today we are fixing that for good. So in this video, we are going to look at the exact tools professional developers use to build bulletproof applications using try, except, and finally. By the end of this short tutorial, you will know exactly how to anticipate mistakes, protect your code, and handle any unexpected surprises gracefully. So when you write your code, things will eventually go wrong. A user might type text. For example, as you can see in this program, a user might type a text instead of a number. So that can happen. Or a network connection might drop. If you do not handle these moments, Python stops running completely and displays a massive confusing red error message. This completely destroys the user experience. So our goal as programmers is to build a safety net around our code. We want to catch these errors while the program is running, fix them behind the scenes, and keep the application moving forward without any interruptions. To prevent these crashes, we use a structure called try block. You take the specific lines of code that are risky. For example, here I have a program and these are the specific lines of code that might cause error unexpectedly due to a wrong user input, etc. So this is a risky code. You place them inside this block. This block is called the try catch, and the first block is the try, and this is called the try block. And you take the specific lines of code that are risky, and then you can put them safely inside this block. So think of this as a Python attempting an action with caution. Python will execute these lines one by one. If everything goes fine, smoothly, the program completes the task and moves right past this error handling logic. So without skipping a single beat, it executes all the lines smoothly. But what happens if an error actually strikes while inside this try block? The moment a line fails, let's say something happens here, or something when you convert this, when the Python tries to convert this number into the input to float, something explodes. So what happens then? The moment a line fails, Python instantly halts the execution of that block. It does not perform the remaining lines of code. It does not execute them. What it does is it refuses to run the remaining lines, as I said, which are inside this try block. And what it does instead is it jumps down to the except block. So this is the except, and you can see here the value error. This is the error you are trying to accept, and that's where it jumps inside to the except block. The except block acts as your defensive shield. So think of it as a defensive shield. So it catches the falling program and gives you a dedicated space to handle the mess. So inside this block, you can use the recovery steps, or you can print a polite message to the user saying that the valid input is valid. Please enter the numbers only, so the user can realize, I typed the text, I should type a number, and the program runs fine. So you can catch you can accept different errors. So if you can handle them gracefully here. For value error, you are handling it with this message, and zero division error, you tell the user that you cannot divide a number by 0. So that's what you have here. So you can print a message like this telling the user that you cannot divide a number by 0, and then the user understands that, and then he subsequently enters a correct number here. So the division is making sense here, and the program runs properly, printing the final message. So that's what you expect. Except blocks, you can have as many blocks inside this. So I have here 1, 2, 3 except. So wherever it matches, if Python say encounters value error, it's going to print this message. And if it is encounters any exception, this is any other unexpected errors. This is like a catch-all block. If Python gets any error other than these two, if it's some kind of a different error, it's going to fall here and it's going to say an unexpected error occurred. So it can happen anytime. So if you enter the alphabet, it says invalid input, but in some cases you can catch the rest of any unknown errors. Maybe it's a network error or some other error. So here we have that comprehensive example. I will share it in my GitHub repo where I put this sample code. So that's how we have this complete tool. So this program, what it does is it takes two inputs from the user, the first number and the second number. The first one is the numerator input and the denominator input, and then it processes them and calculates a result. So this is an excellent example because it demonstrates how to catch multiple errors, specific errors like value error, zero division error, and it will also grab any other error and how to cleanly finish the operation. And this block this block runs only if there are no exceptions were raised. That is, if everything goes smoothly, as we saw here, the division operation attempt completed, which is the final message. If everything runs smoothly, it finally confirms the user that everything happened fine and the program ended. So this is another useful finally thing. And if you can take a look at this, and do you need all these try else finally? So there are three parts you can see here: the try block and the else block and the actually try block, and you have the except and the else and the finally. So that's how you do. And do we need all the try, catch and finally blocks? You might be wondering, hey, if I have a program and do I need to specify all these things mandatory, or these? You do not need to specify them, all of them, but a try block cannot be completely free. You cannot write a program with just try block. It always needs a companion to tell the Python what to do. So try and except is one combination you can use. So when you have a try block, you should always have a except, or you can have a try block and then the most common programmers they use a try block and an except block. You don't need to have a finally block. Or the another option is you can have a try block and then you can skip all of this and then have only the finally block. So you can have the try and the cleanup block. So this finally is called the cleanup block. This is also valid. So try except alone is valid, or the try and finally combo is also a valid. But if you want a full safety net, you need to use all of them: the try, except and finally. So but the only golden rule I can tell is a try block must be followed by at least one except block or exactly one finally block. So writing just the try block itself will trigger a syntax error. So for example, if I use only try block here and remove everything and then try to run this program, it will say expected except or finally. So you should include either a except or a finally block, or include both of them, just like we did it, just like we have here. So in that case, it's a full safety net there. So, and you might be wondering, what if I remove the else block? The else block is completely optional as well, so you can completely remove it. So let's see what happens here. So I remove the completely block and I'm going to run this program, and it runs fine. And you can see it runs fine. The only thing is that the else block is completely optional here, since we have a except block and the finally block. So everything worked fine. So if you like this video, give a thumbs up and don't forget to Leave a comment below if you have any questions about structuring your error blocks. Drop a like. Once again, drop a like if this video cleared things up, and I will see you in the very next video. Thank you.